we've got one more rule to take a look at. This is the constant multiple rule. I'm adding up a bunch of terms. As with the other rules, it does not matter that the initial index is 1. It could be any other initial index. But if I look at my terms, okay, there's this constant c that doesn't depend on I. That same number c is showing up in each and every one of my terms, being multiplied by this other part that does depend on I. And what this says is that you can factor out that constant. If the same constant occurs in a bunch of terms, in all of the terms, you can factor it out, add up the a parts, and then multiply by c at the end. Okay. Let's actually look at an example. Let's suppose I had the sum as I goes from 1 to 3 of 2i. Okay. So that constant 2 shows up in every single term. Well, I could say this is 2 times the sum as I goes from 1 to 3 of I. If I worked this one out, my index I is going from 1 to 3, and I'm just doubling the index. So when I is 1, I get 2. When my index is 2, I get a 4. And when my index is 3, I get a 6. Now, according to this rule, that's the same as taking 2 and multiplying it by this sum. I goes from 1 to 3. My index matches my term. So it's just 1 plus 2 plus 3. Okay. Well, let's see. 2 plus 4 plus 6, that's 12. This would be 6 times 2 is 12. Either way, I get 12. And I can see this is actually just the distributive law. Here's this 2. If I distribute it to each one of these pieces, I get these 3 terms. Equivalently, since each one of those terms is even, I can factor out the 2. I can undistribute it to put it on the outside. So that's our third rule of 3. So those are the 3 rules that we have: addition, subtraction, and multiplication by a constant. We don't have a rule for if we have 2 parts that do depend on I and are multiplied together, but we do have a rule if we've got 2 factors and one of them is constant.